Hello guys, welcome back to my channel. This is Meghna from Sri Venkateswara College of Engineering. Today I am going to explain about the topic under the subject name of Design and Analysis of Algorithms under the subject code 21 CS42. Today's topic is graph searching algorithms, graph search or graph traversal algorithms. Explore a graph for general discovery or explorative search. They will try to visit as much of the graphs as they can reach, but there is no expectation that the paths they explore are computationally optimal. The graph search algorithms are usually used as a core component of other algorithms. Graph searching algorithms: breadth first search, depth first search, bidirectional search, digital algorithms. There are mainly two types of graph search algorithms. One is depth first search and breadth first search. Firstly, we are going to explain about depth first search. Depth first search starts visiting vertices of graph at an arbitrary vertex by making it as having been visited. One each iteration, the algorithm proceeds to an unvisited vertex that is adjacent to the one it is currently in. This process continues until the dead end, the vertex with no adjacent unvisited vertex is encountered. At the dead end, the algorithm backs up one edge to the vertex it came from and tries to continue visiting unvisited vertices from there. The algorithm eventually off after backing up to the starting vertex, with the latter being a dead end. By then, all the vertices in the same connected component as the starting vertex has been visited. If the unvisited vertices still remain, the depth for search must be restarted at one of them. It is inconvenient to use that to track the operation of depth first search. We push the vertex onto the stack. When the vertex is reached for the first time, that is the visited of the vertex starts, and we pop the vertex off the stack. When it becomes a dead end, that is the visited the vertex end. Algorithm for depth first search. Depth first search implements a depth first search traversal of given graph. Input: graph G is equals to V, E. Output: graph G with its vertices marked with consecutive integer in order of their being first encountered by the DFS traversal. Mark each vertex in V with 0 as a mark of being unvisited. Count 0. For each vertex V in V, do if V is marked with 0, DFS V. DFS V visits recursively all the unvisited vertices connected to vertex V by a path and numbers them in the order they are encountered via global variable count. Count is equal to count plus 1, mark V with count. For each vertex W in V adjacent to V, do if W is marked with 0, DFS W. For the adjacent matrix representation, the traversal time is theta of V into 2, and the adjacent list representation it is in theta of V plus V E, where V and E are the number of graphs, vertices and edges respectively. Breadth first search. It is another technique of graph searching algorithm. It proceeds in a concentric manner by visiting first all the vertices that are adjacent to the starting vertex, then all the unvisited vertices to edges apart from it, and so on, until all the vertices in the same connected component as the starting vertex are visited. If there is still remain unvisited vertices, the algorithm has to be restarted at the arbitrary vertex of another connected component of the graph. It is convenient to use a queue to trace the operation of breadth first search. Algorithm of breadth first search (BFS). It implements a breadth first search traversal of the given graph input. Graph G is equals to V, E output. Graph G with its vertices marked with consecutive integer in the order of they have been visited by the BFS traversal. Mark each vertex in V with 0 as the mark of being unvisited. Count 0. For each vertex V in V, do if V is marked with 0, BFS V. BFS V visits recursively all the unvisited vertices connected to the vertex V by a path and assign them numbers in the order they are visited. Via global variable count, count is equal to count plus 1, mark V with count and initialize a queue with V. While the queue is not empty, do for each vertex W in V adjacent to the front vertex do if W is marked with 0, count is equal to count plus 1, mark W with count. Remove the front vertex from the queue. Breadth first search has the same efficiency as the depth first search. It is in theta is equals to V square and the adjacent matrix representation, and theta is equal to V plus E for the adjacent list representation. In conclusion, graph searching algorithms play a fundamental role in various fields of computer science, artificial intelligence, network analysis, and more. These algorithms enable us to navigate and explore complex relationships within the graph structures efficiently and effectively. The choice of algorithm depends on factors such as the characteristics of the graph, the problem we solved, available heuristics, and consideration of the optimally and efficiency. Like, share, and subscribe. Keep supporting. Thank you.